Okay, it's already 10 and let's start it. Share my screen. Okay, hello everyone. Welcome to our Q&A session again. So today our topic is about the radical numbers. So before we start, let me introduce myself. If you did not meet me yesterday, if you don't know who I am, so I'm your teacher for this Q&A session. My name is William. And some fun facts about me is that I'm a cat person, and I'm also a super fan of road trip. You can see here's my Google Maps. Those red marks are all places of visiting through driving. You can see that I drove along the West Coast and also drove across the American continent. Okay, that's all about me. And let's start our class today. So our topic today is radical numbers. So there are three major components of radical numbers. The first one is the largest one, which you can notice at first day, which is radicand. So this number here is 27, for example. This is the radicand. And the second one, you can also notice that here is a radical symbol, which is this one, written in this way. And the last one, we got the index. So these are all three components of our radical numbers. So if you can notice here, this is 3, that made it course as cube roots. What about square roots, right? So you can imagine that for the square roots, the index is equal to 2. That means, for example, we want to write as square root of 4, for example. We can write it in this way. But you haven't seen it at all, right? That is because we can directly omit this 2 if we are doing the square root. And that is because the square root is actually coming from our yesterday's topic, which is, if anyone can remember what we talked about yesterday, right? So yes, if we are writing as 2 to the power of 2, we are writing it as 4, so that when we are doing the square root of 4, it is equal to 2 for this time, for this case, right? But if we are writing as 2 to the power of 1, that is to say that 2 only need to multiply by itself for 1 time, so that is 2. So there's no need for any symbol for it for this time. So that is the reason why we started from the square root. So that means we don't need to specify these 2 for this case as an index. Okay, I think that is pretty enough for our students. Okay, let's move on to our square roots. One thing you should remember is that all positive numbers A have 2 square roots, which is square root A and a minus square root A. That is because the first one is a positive one and the second one is a negative one. So both of them got the same absolute value. So for example here, the square roots of 4 are 2 and minus 2, right? So let's see here. So if we remember yesterday that 2 to the power of 2 is equal to 4, right? Then the square root of 4, can we write directly as 2? No. Why? The reason is that not only 2 to the power of 2 can get the answer of 4, but minus 2, the negative one, right? If we write it this way, this is also equal to 4. So we got another answer for this one, which is minus 2. That is the reason. One thing we need to notice that in the US, we got some very specific habits. For most of conditions, we omit this situation. So sometimes if you didn't see a minus symbol before the square root, that means it is a positive one. So when you are doing the operations, you can like think about this is definition, but for most of the case in the US, we just pick the positive one. Okay, all right. Now let's take a look of the cube roots. So 2 to the power of 3, that is 8, as we mentioned yesterday. So then the cube root of the 8 should be, of course, 2. Then why there's no minus 2 for the answer of this one? That is because if you put a minus 2 here and you did it as the to the power of 3, that means you multiply it for 3 times, right? The answer is still minus a, not positive a. So that means for the positive a here, the answer can only be the positive 2. Okay, I think that's all for the square root and cube root. But also we got some specific situation here. What if our a is equal to 0? So if we write from this way, for example, 0 to the power of 2, which is 0 multiplied by 0, which is still 0. So if we did a square root for this one, 0, that is 0, right? Okay, so that means if you see 0 here inside the square root, the answer is always 0. Okay. Okay, that's all for our definitions. Let's move on to our questions. So for our first question, write the square root of the following number. So for 49, of course, we know that 7 to the power of 2 can be 7 multiplied by 7, which is 49, right? So 7 can be the answer, but also minus 7 to the power of 2, which is equal to minus 7 multiplied by minus 7, which is also 49. So that means we got 2 answers, which is a positive one and a negative one. So we got a both positive and negative 7 for this one. Did you get it correct? Okay, so let's move on to our next question. Our next question is 1.21. So you may know that 1.1 to the power of 2 can be 1.1 multiplied by 1.1, that is 1.22, right? But also the same as our first one here, in minus 1 and negative 1, right, can be also writing this way. So that is also 1.22. So actually we got 2 answers for this one as well. Okay, right. Okay, please mute yourself. Okay. All right, moving on to our next one. Our second question is that the square root of 4 to the power of 2, right? So this one is very simple because you can use your logic to think about that. We do the power firstly, and then we do the square root. That means this kind of square root can be directly, right, deleted because we got this power to the power of 2 here. So we can directly write it in this way as 4. So the answer for this one is 4. Can we do this for our next one, the minus 15? Can we directly write as minus 15? No, we cannot do that. Why? Because there is a kind of procedure of operation. So we need to first calculate the value inside their square root. That means for this case, what we need to do firstly is to calculate minus 15 multiplied by minus 15, right? This is a minus 15 to the power of 2, and that is a positive 225. So then we need to do the square root of positive 255, which we can get positive 1 and also a negative 1. But as I mentioned, that in the US, we got a kind of tradition that we only keep the positive 1 during our operation. So that means you just need to keep this 15. So the answer for this one is 15. Okay, let's move on to our next one. So please note that the index here is 3. So that means you're thinking about which number to the power of 3 is equal to 64. So let's try 4, right? So 4 to the power of 3, which is equal to 4 multiplied by 4, and then multiplied by 4. And that is 64, right? So also, can we directly write 4 here? No. Why? Because we get this one, a minus symbol here. You must notice that this minus symbol is not inside of this parenthesis, right? So actually we separated, we did this 64 and we got this 4, and we need to keep this minus symbol. So that means minus 4 will be the answer of this one. Did you get that correct? Okay, let's move on to our next question. Question number 4. Let's do a very simple operation. So we got square root of 6 multiplied by square root of 12. So what we need to do for this one is we got both of them are square root, and we got a multiply symbol here, right? So this one, and we got square root, right? So what we can do for this one is directly write it as this one, as square root symbol, and we directly multiply what inside them, which is 6 multiplied by 12, right? And then which is 3. So what we need to do is 6 multiplied by 12. That is how many? 72. So we can write it in this way. Is this the final answer? No, it looks like a final answer, but of course you can think that, okay, 72. I may do more things to simplify the square root of 72. So what you can do to simplify it is to firstly trying to figure something out of it, right? We wanted to make it something out of it, and we keep our simplest answer inside of this square root. So what we can do for right now is that trying to figure out the GCD. If you remember the GCD yesterday, so 72, and we did it for 2 directly because we don't need to do for the 1. So if we did it 2, that is this one, right? 36. So are there any kind of square root for 36? Oh, yes, of course, right? 6 to the power of 2 is equal to 36. So we can firstly separate the 6 out of here. So we can write it as 6. And what we left? 2, right? So 2 is still left inside it. So we got 6 and square root of 2. That is answer. Okay, I see someone is typing in the chat box. That is perfect. We got it. Okay, so this is question number 4. Let's move on to the next one. Question number 5. Let's do comparison. So 2 and square root of 6, and another side is 5. Which one is larger? Which one is smaller? What we can do for this one is to, of course, we don't want the square root symbol. We cannot compare it with the square root symbol. So what we can do is to did it as this way. We put the power back right? So we put it to the power of 2, and then we get 5 to the power of 2, right? So we get 2 sides as this way. And what we can do for this time is that 2 to the power of 2, of course, it is 4. And 6 to the power, square root of 6 to the power of 2, which is 6. Of course, in this way, you are finally getting rid of this square root symbol. And don't forget, this is a multiply, right? So the answer of this one is 24. Then what about this one? This 5 to the power of 2, of course, is 25. So 24, of course, is smaller than 25. So that means this one is also smaller than 5. Okay, we solved question number 5. And let's move on to our last question, which is the most difficult one. It's an MSc question. So let's do it together. What is the value of this stuff plus this stuff, right? Okay, we see at least, wow, there's so many square root symbol here. But what should we do, right? Let's note that there is a larger one. There's a larger square root symbol, and we get it 2. This is the power, right? To the power of 2. So that means we can directly put them, but, right? Yeah, and also we don't need this one here, and this one, right? But, okay, out. Is that okay? This is not okay. Of course, not okay if you remember of our comparison question, because we also need to compare 3 and this one, right? Because this is a minus symbol, we need to make sure this part inside it is larger than 0. Or if it is not larger than 0, we need to take the absolute value, right? So for this case, we need to do the comparison firstly. So we get 3 and 2 square root 3, okay? So how can we do the comparison? Of course, add the power back. So that is how we get the power back, right? So 3 to the power of 2, that is 9, which is first symbol. This one, 2 to the power of 2, that is 4. And don't forget this is multiply, and this is 3, right? So which is 12. 9, of course, is smaller than 12. That means this one, 3, is also smaller than 2 square root 3. What does that mean? That means if you did it here, if you put a minus symbol here, right? 3 minus 2 square root 3, that must be, let me write down it here, that must less than 0. So what can we do? We want to take the absolute value, right? So we turn it to this way. This is the absolute value. Okay. So what is the absolute value of this one? Of course, this one, right? This is absolute value. Okay, we got it. Let me see the chat box. Okay, let's do it later. So let's move on for this one. Okay, so for this part here, of course, it's about 0. So we don't need to take care of this one. This one we can directly write as 3 plus 2 square root of 7. Okay, so that's all. We got it. So this is our answer for the first part, and this is our answer for the second part. We add them together, right? That is this one. Okay, so that's all for our questions today. Okay. Let me take a look at the chat box for any answer. Yes, I see a hands up. Let me see. do check out first. Number 7 was wrong. Okay, for number 7, the answer is you didn't do number 7. Oh, okay, okay. So a lot of you want to do question number 7. Okay, so let me pause share first. Stop share and let me stop recording.